In the previous video, we defined the tan of an angle theta as the opposite over the adjacent. But the opposite and adjacent are only two sides of a right angle triangle. We could have picked another pair, for example, the opposite and the hypotenuse, or the adjacent and the hypotenuse, and our results would not have differed because the ratios would still be constant. It's true that the ratio of the opposite to the adjacent is different to the ratio of the opposite to the hypotenuse, but for a particular angle, the ratios are the same no matter what the triangle is. Let's see what that means. If we take the ratio of the tan, if we define the tan as the ratio of the opposite over the adjacent, this ratio is constant for a particular value of the angle theta. And as we have seen, that tan 40 is the same in any triangle. We can define two other pairs of ratios. The first one is sine theta is the opposite over the hypotenuse, and cosine theta is the adjacent over the hypotenuse. So those ratios are the three ratios that you need to remember. Now, because sometimes people find it difficult to remember which pair of sides works together, there's a nice way to remember them, and that's by saying SOHCAHTOA. SOHCAHTOA refers to S for the sine, O for the opposite divided by the hypotenuse. So Ka is C for the cosine, A for the adjacent divided by the hypotenuse. So Ka, and Toa is that short for tan equals the opposite over the adjacent. You need to remember these. Let's see how we apply them. Let's say that we have this right angle triangle with an angle of 55. And let's say that this side is x units long, centimeters in this case. The right angle is here, so this is the hypotenuse. And as far as the 55 degrees is concerned, this is the opposite. Now you ask yourself, which trigonometric ratio connects the opposite and the hypotenuse? And that's the sine. So sine 55 is equal to the opposite, which is x, divided by 12, which is the hypotenuse. Cross multiply, you get x equals 12 times sine 55, and let's do that together. 12 sine 55, and as you can see, that's 9.83 centimeters to the nearest to three significant figures. Let's take another example, and it is related to this one. Someone might say, but hang on a minute, I don't want to use this 55. I know that this angle is 35 degrees because the sum of the two acute angles in a right angle triangle is 90. They are complements of each other. So if someone decides to take this 35 as the reference, this is the hypotenuse, it does not change. But this becomes the adjacent as far as 35 is concerned. And this person would ask themselves, what is the ratio that connects the adjacent to the hypotenuse? And that's obviously the cosine. So cosine of 35 is equal to the adjacent divided by the hypotenuse, which is 12. Cross multiply, that gives you 12 cosine 35, and yes, that gives the same answer. And if you don't believe me, let's see. 12 times cosine of 35, and that's exactly the same answer. So it really does not matter which angle you take into consideration, as long as you get the order of the sides and the naming of the sides right. Now, this is a new idea of solving a triangle. Let's see what that means. Solving a triangle involves finding unknown sides and unknown angles. If this angle is, let's say, 58, and this angle is 14, this side is 14, I mean this is a right angle. Obviously you can work out this angle as 32. So you have discovered all the angles in the triangle, but there's still the hypotenuse that's unknown and there's x that's unknown. You can decide if you wish to take the tan to calculate x, and if you base your work on the angle 32, then this will be the opposite and this is the adjacent. So tan 32 equals 14, the opposite, divided by x, which is the adjacent. So by a little rearrangement, cross multiply, divide by tan 32, you get x equals 14 over tan 32, and that's 22.4 centimeters. Obviously you could have used the 58, but in that case the x would be the opposite and the 14 would be the adjacent, and you still get the same value. Now once you establish that this angle is, this side is 22.4 centimeters long, you can work out the hypotenuse using Pythagoras theorem. 14 squared plus 22.4 squared under the root, and that's your h. But remember, the 22.4 has already been rounded. We did not get exactly 22.4. So in order to maintain accuracy, you are advised to use the numbers that were given in the question, and or at least the numbers that you know are exact. So let's work on the 32 now. We already have the 14, and it's better to use the 14 rather than the 22.4 because this is exact. And we want to work out the hypotenuse. So as far as the 32 is concerned, this is the opposite, and this is the hypotenuse. And obviously the ratio that connects them is the sine. So sine 32 equals the opposite over the hypotenuse, 14 over sine 32, and that equals 26.4 centimeters. Now, you can check that 22.4 squared plus 14 squared under the root is equal to 26.4, and obviously it will be because Pythagoras theorem holds.